Today we will discuss the question number from 11. Propene on reaction with HOBr. What is the major product P? When HOBr, Markovnikov rule is followed here on addition of HOBr. When this pi bond is moving towards the CH2, then it forms secondary carbocation. Then here, according to electronegativity, OH is negative charge, Br is positive charge. Therefore, this negative part attack at the positive and this positive attack at the CH2. Like this, OH attack at the second carbon. Which option is there? That is the second option. Now, 12th question is propene react with the Cl. In these two, which is more electronegative? Chlorine is more electronegative. That's why bond shifted toward the Cl. Therefore, Cl minus and I plus. Same thing when pi bond shifted towards to the CH2, then here secondary carbocation form. Then Cl minus attack at the secondary carbocation. Then at second position Cl, that is which option is there? That is also second option. Then next question is which of the following is the correct for the reaction? Propene react with the HBr in presence of peroxide. In presence of peroxide means that is called anti-Markovnikov rule. Anti-Markovnikov rule. It means opposite to the Markovnikov rule. Then here H plus this is and Br minus. Generally Br minus attack at the less number of hydrogen bonded carbon at according to Markovnikov rule. But now anti-Markovnikov rule, negative part of the reagent bonded to opposite meaning that is more number of hydrogen carbon. This is so now Br attack at the CH2 carbon. So here option is anti-Markovnikov addition, that is correct. So no product, right? If you want the product is the CH3 CH2 CH2Br is the product. Next one, 14th question. Toluene chlorination in presence of H nu. H nu is there meaning that is compulsory side chain substitution or heat is given side chain substitution. Therefore, now on this benzene, how many hydrogens are there? CH3 means 3 hydrogens are there. So all hydrogen may replace or one hydrogen may replace according to option we have to select. In the first option, this chlorine is on the benzene ring, that's what is not correct answer. And second also on the benzene, not correct answer. Then third option is the correct, one hydrogen is replaced, therefore CH2Cl. Fourth option also on the benzene, that's why this is not the correct option. That is called electrophilic substitution. That is not. This is a free radical substitution is correct. That is the third option correct. Now 15th question. One alkane on the cyclobutane and methyl group is there. Methyl cyclobutane. Bromination in presence of H nu. Bromination in presence of H nu mean always we have to think about the free radical substitution. Therefore, generally, which free radical stable? Tertiary free radical is more stable than the secondary. Secondary is more stable than the primary. Now, if here is bromine substitute, that is the primary. Here bromine substitute meaning that is called tertiary. And these positions are called secondary position. Therefore, which is the major product meaning a tertiary substituted major product? That is the third option. Then 16th question, which is the most stable radical? Generally, benzyl free radical more stable, allyl free radical more stable than tertiary. So here this is a methyl free radical, this is a allyl free radical. This is called allyl free radical. This one third option is called primary free radical. This fourth one is aryl free radical. Aryl free radical is very unstable, therefore the most stable free radical is the second option. Now 17th question, benzene on iodination in presence of HNO3, that is called electrophilic substitution reaction, therefore that is on benzene iodination takes place, that option is the second one. Now 18th question, toluene react with the bromine in presence of Lewis acid, that is a FeBr3. The reaction is called electrophilic substitution reaction. Already we studied. Then third option is the correct, because first option nucleophilic substitution, then second one is a free radical addition, fourth one is free radical substitution. That is not correct, because Br bromine molecule in presence of FeBr3, this will generate the electrophile Br plus and plus FeBr4 minus. This electrophile substitute on the benzene Br plus, like this convert. Therefore here hydrogen every corner and Br pi bond and here positive charge. So this is called electrophilic substitution reaction. Now 19th question, benzene disonium chloride, cuprous chloride and HCl, this is called Sand-Meyer reaction, direct preparation. So on this what it gives the chlorobenzene is the product, that's why Sand-Meyer reaction. Now physical and chemical properties respective question. Now 28th question is, given compound or reagent, then it converted into one bicyclo compound, the reagent R is. Now these two are bromine in presence of sodium in ether, that is called Wood's reaction. Then here 1 2 3 4 carbon ring like this form, therefore that is called fourth option. Next, which of the following halogen exchange reaction will occur in acetone? Generally we know Finkelstein reaction is in acetone solvent takes place, that is called Finkelstein reaction. So Finkelstein reaction, generally alkyl halide, generally chloride bromide with the sodium iodide, that is the correct option. So third option, because this will come to Ri plus NaCl in acetone solvent. In acetone solvent, this is a more ionic character, that's why there is no backward reaction. That's why you can take the RCl or RBr, they are less soluble in the acetone. So compulsory what is required in the Finkelstein reaction? NaI is another reagent required. So third option correct. Second one, which is the most reactive nucleophile in the polar protic solvent? Most reactive nucleophile in the polar protic solvent. Polar protic solvent mean the water, like this alcohol, like this are called polar protic solvent. In this one, F minus is a smaller and more electronegative. This will be hydrogen bond formed with the water molecule. Therefore, this will be totally surrounded with the water molecule. That's why this is less nucleophile character. I minus is the larger size. This is less surrounded with the water molecule. That's why, which is a good nucleophile, meaning a fourth one. Which is the most reactive nucleophile in the polar aprotic solvent? Generally, we know that HF is the acid, then this can be on dissolution, it gives H plus and F minus. Weak acid, this is which one? Weak acid gives a strong base. Strong base are generally strong nucleophile. Therefore, good nucleophile meaning in polar aprotic solvent, this is not solvated, it is a good nucleophile. Therefore, F minus is a good nucleophile. So in polar aprotic solvent, the nucleophile order is F minus greater than Cl minus greater than Br minus greater than I minus. In polar protic solvent is F minus is the least, then Cl minus, then Br minus, and I minus is a good nucleophile. Then which cannot act as a ambidentate nucleophile? Both side can be bonded, means that is called ambidentate nucleophile. Cn minus means carbon also, nitrogen also can bond, that's what is ambidentate. And nitrogen also, oxygen also ambidentate. Sulfur also, nitrogen also ambidentate. OH only with the oxygen bonded, that's what is not ambidentate. Here they are asking cannot act as ambidentate, answer is a 4. 25th question. Which of the following solvent suitable for SN1 reaction? For SN1 reaction, which is a solvent? Polar protic solvents are suitable for SN1. This is for SN1. Polar aprotic solvent for SN2. So answer is second one. Now the given compound in KOH aqueous. Aqueous word given means generally it takes a substitution reaction. So when Cl is out, then what will form? A 1,2 secondary carbocation is formed. Now 5 member is ring, generally strain molecule, therefore it becomes to expand its ring and convert into 6 member. So when 6 member is converted, this one, then 1 is here. Now we can, for understanding purpose, we can give number. So carbocation, this is a 1, and next is second, this is a third, this is a 4, this is a 5, this is a 6. So first carbon bonded with the, this is a called CH3, then CH3 this one, then this is the first carbon, then second carbon should be carbocation, then second is bonded to third, third is bonded to fourth, fourth is bonded to fifth, fifth is bonded to sixth. Okay, now this is called secondary carbocation. Secondary carbocation unstable, that's why here one hydrogen is there, that will be shifted to here, then this will convert into here carbocation form. This is called tertiary carbocation. Tertiary carbocation is more stable, that's why here OH minus will attack, so that compound is the fourth option. Okay, so that will give the fourth compound. The next 27th question. Tertiary butyl bromide alcoholic KOH. Alcoholic KOH and heat given mean that is called elimination reaction. In this elimination reaction, what will form the product? One alkene form. So that alkene product I am writing here CH2 double bond, one H, one Br out, and this is called CH3, and down CH3 I am writing right side CH3. H, what is eliminated? KBr eliminated, and another one is the water eliminated. Then this is a product form, 2-methyl propene. This is react with the HBr and peroxide. HBr peroxide means anti-Markovnikov rule. So therefore, bromine will be attacked at this position and H will be attacked at this is a bromine, and here hydrogen will attack. Based on that, product is CH2Br and CH and CH3 and CH3. Like this, which compound is given meaning So Br says first one, the reverse it is given. This is the first one applicable. Here OH is the wrong answer. Here Br to the secondary carbon, sorry tertiary, wrong answer. Then which is the answer mean first option.